So, what we are going to talk about today is top-down design along with bottom-up design. We talked some last semester about the philosophy of what top-down design is, and we're going to kind of revisit this stuff when it comes to functions and what we know about functions, and also talk about how we can create our own libraries and our own namespaces, because you totally have the ability to make your own library of functions and make your own namespace, not just like the standard namespace that we've been using over and over again. So the idea of functions, they work well if you're designing a very large piece of software. If you're doing the top-down approach, you just try to take a really, really huge task, break it down into smaller pieces, and then realistically speaking, you're going to have like massive teams of people who are all coding stuff simultaneously. And so, one person might be responsible for like the graphics package. And then you might have, if you're doing something like one of those video games that's got a pretty involved story, other people work out the details of like how the graphics work, and then it's their job to like maybe do like the different story branches or whatever for for the for the game that they're designing, whatever it is. What you can also do is what's called a bottom-up approach, where you create a bunch of functions that have a lot of versatility and just they allow you to do different kinds of things. And so this is basically kind of the opposite approach, where instead of trying to plan everything ahead of time, you instead just make lots of functions that do lots of interesting things, and you can just kind of keep building and building up from something small and make something that can be pretty large and involved from those large uh, building blocks. The reason functions are nice for this is that the idea of a function is to separate what a function does from all the other stuff outside of the function. Separation of ideas is a really key component to programming and programming well. The functions should not depend on anything external from themselves. If you have like a bunch of nodes, you have a base node, in this case, the int main program that then kicks off and has a bunch of other nodes that are themselves functions, and then those functions can call other functions inside of them. So an example of how we might do this sort of thing is if we were to make a program for the game Connect 4. And so at a basic level, there are three things that this would need to do. We would need to initialize the game and set up the board. At first, it would be a board that would be blank. The next big thing that such a program would need to do is to take turns. So we would need a series of tasks where it goes back and forth from player to player to ask them where to put the piece and then actually display so that the board has all those pieces. And then finally, if either player has 4 in a row, be it horizontal, vertical, or diagonal, then one of the two players will be declared the winner if they achieve that goal. So within the first thing, if you're setting up, if we're going to initialize the game, that in and of itself would, well, what task one would comprise of is we would get the size of the board and then initialize the board as empty. So the way we're actually going to design this is that the players will have the option of choosing how large of a board they're going to do. What task 2 would consist of is you would display the current board, get the move from the player, place the piece, and then check if there's a winner or a tied game. And then the last thing you would do is you would print the board and then print the winner. So what is it that it entails for checking for a winner? that in of itself has a lot of subsets to it. You'd have to check the verticals, check the horizontals, check the diagonals, and we'd have to do that separately, and then check to see if the board is full with no winner at all. Checking for the winner is really the same as printing the winner because they basically entail the same process. And so there's basically two different places where we're going to show the board to the user before each turn and before we declare the winner. So we can combine some of these functionalities because what we can do is have just like a display board function, and then we could have like just a get winner function or something like that. So what you might do, if you're sketching out some pseudocode for this, you're going to get the board size, initialize the board, initialize the game, actually start the game, and then have your main program there. So for instance, what we might do, we might get the size of the board. So we would pass by reference here. We're going to have columns and rows here, and then we would probably store that information somewhere else. We've got these questions here asking the user how big of a board they're going to play on. So they'll tell us the columns, they'll tell us the rows. I think traditionally Connect 4 is like a 6x7 board. And so that would be like the first component of this. So we can look at just this much of the program, but essentially what this is going to do is it's going to get the size of the board, and then all the program is going to do, we declare a couple of integers, we get the size of the board, columns and then rows, and then we're going to output and just say, hey bro, there's that many rows or that many columns and that many rows. We're actually starting with columns because with the way the game is played, you drop a piece and they build up in columns, which is why we're doing columns first. Traditionally, like in mathematics, they do rows and then columns. But because of the way this game works, columns is going to be the primary driver of how we organize this. So again, this is basically just a simple function where we ask for the columns, we ask for the rows, and all it's going to do is just tell us the size of the board we're going to play on. And so at least for this program, we're giving players the option of how large of a board they're going to play on. But again, this is all sort of the idea of doing something from a top-down design where you're trying to plan everything out ahead of time, and then you kind of branch off and create subtasks within the main task. That's the fundamental idea behind top-down design.